Hello, everyone, and welcome back to another episode of the Trino Community Broadcast. This is episode 52. We've got a fun title for you about Commander Bun Bun taking a bite out of Yugabyte. My name is Cole Bowden. I'm one of the Trino developer advocates. Joining me is Manfred. Manfred, glad to be back again.
Yeah, it's good to run another show with an interesting topic. Yugabyte should be really cool to take a bite off.
Yeah, and this is, I think, the shortest cadence we've had between episodes in a while, with the last one happening just a few weeks ago. So we're back so soon, but we've got a lot to talk about, and there's a lot going on in the Trino community. A lot more to talk about coming up in Trino as well. So
today we're kind of flipping it to the other side, right? Like last time we were Popsicle, so we talked about a client. Today we're talking about a data source. So
yeah, and it's
like the other side of the cluster, so to speak, right? So it's
interesting, cool. Fascinating data source that I think makes a lot of sense to pair with Trino. We'll dive into it a little more once we've done our recap of what's been going on in Trino. But we have Denis Magda, the Director of Developer Relations at Yugabyte, who will be joining us. But before we get to Yugabyte, we have to do our housekeeping. We have to talk about the Trino releases. This week, we're graced with my unofficial highlights. Martin has not posted his highlights yet, so stay tuned to the Trino Slack or LinkedIn for probably better, more curated highlights than what I'm able to throw together.
Come on, don't be so modest, Cole. You know what's going on in those releases, and you're putting good summaries together.
Yeah, so Trino 428, we had reduced memory usage for group by. Trino 430, also I'll jump to that, is improved performance of group by. Dane Sundstrom has been working on the under the hood of aggregations in a big way, and that's going to be paying off with marginal improvements here and there, and some bigger ones as well as he rewrites that code. So stay tuned for that, and that should impact functions down the line as well. 428 added simplified configuration for managing writer counts. It used to be that you had to set a min writer count and a max writer count, and there were a few other things, and it was like 6 different properties. That has been consolidated, so now you can give a target writer count, I believe. And that makes life a lot easier if there's just a number that you want and you don't want to have to tinker with floors and ceilings to see what Trino does. Faster reading of small Parquet files on data lakes. So if you have lots of small files, that's going to go quicker now, which is always nice, because lots of small files can add up to being a lot of data, and that can be a pretty substantial performance improvement if that's how your data is stored.
Also, if you have that performance problem, you should really consider like changing those files and compacting them to larger files.
Yeah, true. we're helping
sometimes
you
just can't. I know, but like just saying.
Yeah, there's multiple things that could be done, but we always try to be as helpful as we can in Trino. And if it's a performance improvement, it's a performance improvement. So 429 has faster. Oh, I forgot the query options on dynamic tables and Pinot. I admittedly do not know a whole lot about what query options are. I'm assuming those of you who use Pinot do, but I've linked to exactly what query options are, so you can read more about that if that's something that's fascinating to you. 429 has faster reading of work files in Hive, more type supported for schema evolution. That's me abbreviating the fact that you can now change various numerical types to other numerical types. Check the exact release notes for specifics on that, but it's just more type changing if needed.
Also, special shout out to Joe Johnson. We updated the docs for that as well with 431, so you don't have to look at the release notes only. You can just look at the docs very shortly.
Yeah, 431 coming out soon. Maybe today, maybe tomorrow. We'll see about that. And 429 also had a variety of interesting security improvements. I'm choosing to highlight the fact that if you're using the Trino web UI and you log out, that'll also log out of your sessions. So you're not logging out of one thing, but still logged into another. It just cuts the connection all in one go, which is safer and more secure and just better practice. So it's a good thing we got that added in. And then 430 had improved performance of group by, which we've talked about. Support for setting time zones on the session level. So it used to be that you had to configure that at larger scale, but if you want to run a Trino session from somewhere else or pretend like you're in a different time zone, you can now set your session time zone and act like you're somewhere else on the globe, which is pretty handy for a wide variety of debugging things. I know that I've run into time zone issues.
It also works the other way around, by the way. If you have a distributed workforce that is all across the globe and you don't want all that different time zones messing up what's going on and you're not understanding, you can basically force the time zone for everyone to be one time zone, and that also helps a lot. So there's both ways that can work.
Yeah, so pretty useful change. Should get rid of some weird, was it on this day or that day based on the specific hour at which it occurred issues. And then table statistics added to the MariaDB connector. So it's useful.
And that's basically only an add-on, like for MariaDB, we already had it in a couple of other connectors. So
yeah. Do you want to talk about what's coming in 431 now, Manfred, or do we should?
Yes, I do want to spill the beans. It's just so exciting.
We'll get there once we've covered Yugabyte. That'll be our pull request of the episode, or more like release highlight of the episode. We'll figure it out.
Yeah.
But for now, I'm going to scroll back up. We're going to pull the release notes off my screen, and we're going to pull Denis in. Hey, Denis, welcome to the Trino Community Broadcast.
Thanks for joining us.
Hello, folks. Yeah, sure, absolutely. And thanks to everyone who is watching us live right now, or if you will be watching us in the future.
Mostly in the future. But Denis, tell us a little bit about yourself. Who are you? Introduce yourself to the Trino community who may not be familiar with you right now.
Yeah, why YugabyteDB and why Trino, and why we decided to put together this live stream. I'm the guy who has been working with databases for the last 8+ years. It just happened. I'm a poor Java developer who eventually switched to that cruel world of databases, and I remained in this world ever since. Before databases, before YugabyteDB and all that, data storage related stuff, I was using Java as a developer, as a backend engineer, and also I spent several years at Oracle building JDK. So generally, that's my story. And as a guy, I like, just to take stuff, hack stuff, and see how, and just educating right now developers to use YugabyteDB, Postgres, and other databases.
Awesome. Well, thank you for joining us, and we'll look forward to see everything in action. Before we do that, though, we have to create a connection between how Yugabyte as a data source works in terms of talking to Trino. And that is our concept of the week, isn't it, Cole?
Yeah. So if you've existed in Trino, if you've written code for Trino, or if you just use Trino, you may be aware of this magical API that's JDBC. In the show notes, I joke that it could stand for just the best connectors, which is not what it stands for. It's Java database connectivity. And it's one of the core APIs by which a lot of the connectors in Trino function. There's a lot of Java-based databases out there. And through JDBC, they can all talk to each other in one unified way. And it's something that is relatively easy to implement. We have an example JDBC connector and documentation for that in Trino. But we figured that today we'd explore how JDBC connectors work, why this is useful, and we're going to be using Postgres as our example.
Yeah, makes sense. Like JDBC, we as application, like those I think who are watching us, application developers or analysts, or like they just find their ways to interact with Trino, right? And you usually interact with Trino by coming up and running different SQL requests of various complexity. And if you want those SQL requests to be executed over a relational database such as Postgres, MySQL, or Oracle, Trino needs to connect to those data stores. And you can use drivers, and those drivers are created by people who build those databases or who love those databases and they want to contribute by other means. So you need to have the driver. That's your kind of connection point between your Trino cluster and between your target database. It's simple, but you usually don't touch it. You just need to provide several parameters in your Trino connector settings, and you're good to go. Trino will handle the rest. Trino knows how to use the driver.
Yeah, it's kind of funny, right? Like it's confusing for some people because there's also a JDBC driver for Trino. So if you have a Java-based application and you want to connect to Trino, you can use a JDBC driver to query Trino. but this is the other end, sort of, where JDBC driver is used. So in that case, it's the JDBC driver of the underlying data source. So our example here is PostgreSQL. And there's various other JDBC drivers. What do these JDBC drivers typically do, Dennis? Like, they just, like, what are some of the APIs that you think these expose?
Yeah, if I'm not mistaken, JDBC is one of the specifications of Java. So generally, in the Java community, folks like to standardize everything. You have many relational databases. And historically, many relational databases, when they started, they had their own version of SQL. Like IBM DB2 would speak one dialect of SQL, Oracle would speak another dialect of SQL, etc. But at some point, the folks came up with a SQL standard. And right now, whether you're in many scenarios, when you create some meaningful application for Oracle and then you decide to switch to Postgres or MySQL, then if you have not used any Oracle specific features, then your application can be switched from Oracle to MySQL or Postgres with little changes. Usually you have difficulties if you create any stored procedures in Oracle. But we have SQL specification standard, we have JDBC standard, and there are databases, many well-known relational databases, they strive to support the SQL standard. And those who create drivers for those databases, if a driver is written in Java, then they try to follow the JDBC specification so that it's easier, let's say, to switch between different databases. And here is, I mean, like, in my assumption, I have not tried to use MySQL or Oracle with Trino, but my guess that for Oracle and MySQL, you also use JDBC driver, but for those databases. So every database has its own version of the JDBC driver. And the driver is like, comes with several, like one of the important steps of this communication between the database driver and Trino backend is, first, Trino needs to open a connection to the database using the driver. You just need to provide a connection address. And after that, you can happily send your queries. You can always fine-tune different parameters by adjusting driver settings, but for the basics, and we are going to look at the basics today, you just need to know the address of your database, and you need to provide a special connection string to the driver. That's it.
Awesome, that's interesting. So basically, the JDBC driver then, like, sends a message to the database that says something like, give me, like, that table, those columns, and whatever.
Every database supports its own protocol. There is like Postgres has its own wire protocol. It's like a network layer or communication layer protocol. When you want to open a connection with Postgres or send a query for execution, you need to send a special message, like following some format. But that's easy to support. And the drivers for Postgres implement this. MySQL drivers implement the MySQL protocol for the communication, and the story continues. But
okay,
after that,
so I'm confused now, or like, well, I have a follow-up question, so to speak. So we were talking about the PostgreSQL driver, the MySQL driver, but today we want to talk about YugabyteDB. So how does that work? Like, what's the difference between YugabyteDB and PostgreSQL if we are like using the PostgreSQL connector or whatever we're using there? Tell us more about Yugabyte and how the relationship works between Yugabyte and PostgreSQL.
Yeah, like,
what's
I remember
the differences?
The first time we met with you and we had that conversation about YugabyteDB, Postgres, and Trino, we discovered that there is no any specific integration for YugabyteDB on the Trino end. But then how would you use YugabyteDB as a data source for Trino? It's simple. YugabyteDB is built on the PostgreSQL source code. YugabyteDB is a distributed database that will scale your data across several database nodes, and then all of those nodes will be handling your read and write requests. And as long as the upper half of YugabyteDB is built on Postgres, on the Postgres query engine, then we inherit a lot of the good properties of Postgres. Most of the application libraries, frameworks, and drivers and tools that were created for Postgres will work with YugabyteDB out of the box. Sometimes it can be a lift and shift story. Sometimes you will be able to migrate, let's say, from Postgres to YugabyteDB easily, but you still might need to introduce some optimizations because you are switching from Postgres, which is a single server database, to a multi-server, to a multi-node YugabyteDB cluster, which means that you migrated probably without any code changes, but then you can do some load testing, performance testing, and you might need to optimize some of the queries because right now those queries are running across a distributed storage engine. But that's easy, and that's the goal of today's show. Is just I want to start with Trino, working with a Postgres instance. We will run some application workload, and then we will try to we will switch this application workload to YugabyteDB, and we would try to switch Trino to YugabyteDB and run a few other experiments.
Awesome, that'd be cool to see. It's very interesting. So it is actually PostgreSQL with more bells and whistles, and who runs it? Am I running this YugabyteDB on my data servers, or?
It's open source. It's Apache 2.0. It's on GitHub. You can download it, you can install it, and you don't need to pay a penny to YugabyteDB. But certainly, we live in the cloud-native world, and there are many options. You can use YugabyteDB as a managed service on every public environment. We have another version of the product for private data centers, for private clouds. But generally speaking, you have a huge open source user base, similar to Postgres. Like most of the Postgres users, they use Postgres for free, and same stands for YugabyteDB. No differences.
And then the reason you would use this over Postgres is that distributedness, right?
We do not compete to Postgres. We complement Postgres. So generally, for me, YugabyteDB is distributed version of Postgres. It doesn't.
Exactly.
It will not support, or it's not 100% Postgres compatible, because the only 100% compatible database with Postgres is Postgres. But YugabyteDB is feature compatible and runtime compatible. It supports all the essential stuff, all the key extensions, etc. And the reason why you would do this, when sometimes you can run out of the Postgres, you can just get to some physical limitations. You might not have enough space in your storage, or you might not have enough CPU cores to run your workloads on Postgres, and you want to switch to something that can scale both vertically and horizontally. So when you need scalability, that's the first reason. Another one is high availability, because with Postgres, in Postgres ecosystem, there are various solutions for the disaster recovery, for high availability, but with YugabyteDB, you just deploy as multi-node cluster across several availability zones, data centers, or regions. You select your deployment option, and after that, the cluster will take care of their fault tolerance. If anything goes down, the nodes will figure this out, and your application will continue operation without any data loss. So this is what we do. We make high availability easy, seamless, and possible for Postgres. And another one is related to the modern stuff is we live in this global world when our users are across their world, and we want sometimes to pin user data to specific locations in the United States, let's say Australia or Europe, for data regulatory requirements or for low latency. And this is also what YugabyteDB supports out of the box. Today, we will see, if the time allows, we will see the high availability. We certainly will see the scalability. We are going to run a multi-node YugabyteDB cluster with Trino, and then I will try to, break things a little bit, by killing one of the nodes and see what happens with the application with Trino. It can fail, literally. Usually it works 100% of the time, but sometimes it fails.
And so I wanted to ask that just because I wanted to highlight the fact that when you're using this distributed multi-parallel processing massive query engine that's all about scale and performance that is Trino, it makes sense to have a storage solution that also can scale and do these same horizontal and vertical extensions that allow you to go literally as big as you could possibly need with data. There is no amount of data that will overwhelm these systems, which is what you like to hear. It's people like to ask, does it scale? And the answer is yes.
Yeah, Trino, in my understanding, Trino is for analytics, YugabyteDB is for transactional workloads.
Exactly.
It's just a very specific, separation between two databases. So some people ask, hey, can I use YugabyteDB for analytics? And we usually say, if you can use Postgres for your analytical workload, then you can use YugabyteDB. But we are not optimizing YugabyteDB for OLAP. Our territory is OLTP, and that's a huge and hard territory to be in.
Yeah, it feels like it's even more distributed than Trino. Trino, typically you have one cluster, right? And But you are basically saying you have one cluster, but you have like sort of multiple master nodes, and like they can like be connected from different places. So I'm really looking forward to see this in action a bit more. So
yeah, it's a multi-master. It's a multi-master architecture. Yeah, it's multi. Every node is both primary and secondary in the sense that you have this table and you shard this table across that cluster. You distribute the data, and let's say one subset of the data will be on one node, meaning that that node will be handling read and write requests for that data. The other node will be handling the read and write workloads for the other subset of the data. And then they also keep the replica copies of this data because this is a transactional database. And we assume that the cluster and the zones and regions and data centers will fail, and we cannot allow ourselves to any data inconsistency or data losses. But that's a database. Yeah, it's shared nothing architecture, meaning there is no any coordinator, nothing like that. Each YugabyteDB node can talk to each other to decide on the data distribution, on the transaction coordination, on fault tolerance, and etc.
Wow, cool.
All right, do we want to move on to demo time?
All right, yep, let's do that. Let me share the screen. All right, that's what we've got. Just empty command line. What I have, I'm going to use Docker. You can deploy in Trino and YugabyteDB and Postgres whenever you like. I've already, I think, studied containers. I have Postgres running. I have a 3-node YugabyteDB cluster running. We will get into this really quick. Trino container is stopped for now. I did this purposefully because I wanted to show you how to add a Postgres connector of Trino to the engine. So my Trino data is located under the following folder. I have this catalog here, and let's take a look. I have this Postgres properties file. So I create this Postgres properties file, and if everything is defined properly within this file, then we will have this data source available to Trino in runtime. That's the point, right? Let's take a look what's inside. Well, simple, because Postgres and Trino, they are running in the same Docker environment, and they will be able to see each other. So here is we are defining connector name, Postgres, and Trino has a Postgres-specific implementation that uses that JDBC driver that we discussed. Mm-hmm. That's what you need to change. And this is, what you need to do to get the driver connected to Postgres. You need to say our driver is JDBC. That's why we have JDBC here. Then we are saying that we are connecting to Postgres. Postgres dialect, and after that you have the address of your Postgres instance. This is how my container is named in Docker, PostgreSQL. So here is PostgreSQL. And then the port number and the default database to connect to. And then username and password. Simple, right?
And by the way, for those of you that are worried there's clear text passwords there, you can secure all that in Trino.
Oh yeah, unfortunately.
We're using dummy data for this.
Yep. Exactly.
Yep. So now let's start our Trino cluster. And I hope that everything is going to work fine. But in the meantime, let's connect to this cluster. And they will open the command line session. Okay. Make it bigger. Now, once we're connected, we can see schemas, but from Postgres. Okay. Yeah, we have a few schemas, and this is a verification that our Trino engine managed to connect to my Postgres instance in Docker. So far, so good. And here is I have this public schema. Let's see, usually by default, when you create a table in Postgres, if you don't define any schema, all the tables will be added to the public one. So we can check from Postgres, public. Yeah, do we have anything? No, we don't have any tables, which means that we need to start some application workload, correct? For that, I prepared a simple application. That application is called Market Orders application. Basic Java application that subscribes to a stream of fictitious market ticks. Like there is some service in the internet that generates different market ticks and trades, and you can subscribe to it and you can do whatever you want with those trades. So that application will be connecting to the service, capturing all those market orders and storing into my Postgres database. So that's the point. How do I start it? I am going to start this application also in Docker. The container name will be market orders instance. And here is one important, the most important configuration here is this Postgres Docker properties file. So this is the application, what it does. It's also going to use this data source. This is the Java stuff. If you're using Node.js, Python, or any other technology, then you would have a Postgres driver created for that language or framework. I'm going to use this Postgres simple data source that relies on the JDBC driver, the same JDBC driver that Trino uses. And then I'm telling, okay, yeah, connect to this Postgres instance. That's the name of my Postgres container, and that's the same username, password, and database that we use for Trino. That's it. Similar configuration. The same driver. So let's start it. Okay, we connected. We connected to the market order stream, and right now you can see that we are streaming the first trades. And here is you have also we are querying the database every 2 seconds to list the most popular stocks, the stocks that people like to buy the most. Okay, so now if we go back to Trino, and right now we can take a look at this Postgres public schema. What are the tables? You can see that, yeah, this application created 2 tables, buyer and trade, and also there is a materialized view. We are not using this materialized view at this time. So that's simple, right? This is how you can quickly create a connection between Trino and Postgres, and this is how you can work with them. For instance, certainly can use SQL. Let's connect, let's count the number of trades that we have in the trade table in Postgres. Simple iteration. If you keep executing it, you can see that this number keeps changing, and this number is very close aligned with what you see on the application end. Also,
so it is basically live getting the data and pumping it in as it comes, sort of like an event capture.
Absolutely, absolutely. You just connect it from Trino to Postgres using the JDBC driver. The connection is opened, and you keep sending those requests, and then Trino gets data from Postgres. Something is done on the Postgres end, something is done on Trino, but eventually the users get results from the place where they executed that query. Also, you can run more sophisticated queries like, this one is way too sophisticated, like this one. Yeah, what this one does, it returns the most popular stocks that are being it's similar to the query you see here on the application end. You just need symbol is the name of the stock, and then we are just calculating the bid price for every symbol. We group this stuff, and eventually you will find the most popular stocks at the given moment. So that's what you have. Okay. Mm-hmm.
Some familiar names and some not so familiar at all.
Yep, exactly. I also don't know what's Elerium is or linen cloth. I don't know. If we can go wild and you can also use Trino to join data that is stored in different Postgres tables. Like here is we want to get the most active traders. We are querying data from the Postgres buyer table, and we are joining this data with their trades. So we basically want to find the first name and last name and how much that person spent in total. So this way we want just to find who are the most active traders at the given moment. Arnold Mazer and Sam Newman, etc. Okay. These are the basics, right, that the folks should already know, if you use Trino. Where is Yugabyte? So imagine right now that this application, this market orders application, gets some traction. It becomes popular. The volume of the data keeps growing. And so there are a number of user requests. You need to scale. You need to be able to scale not only vertically, but also horizontally. And also, right now, I'm running a single server of Postgres, which means that not only I want to scale beyond the single server capacity, but also I want to be able to withstand potential outages that can happen with our database servers. And here is when the story for YugabyteDB starts for many. So for that, let me just interrupt this application for now, because we are going to
we are overflowing already, right? So need to check and get something better, right?
if everything is right for you with Postgres, keep using Postgres. This is a wonderful database. If you need to switch to something that is distributed and highly available, you have an option as a Postgres user. You have YugabyteDB. So YugabyteDB cluster, it also runs in Docker. And we can go connect through the SQL interface, so we can use this UI. So what I have here, I have a 3-node cluster running. That's the internal IP address that was assigned in Docker. Some default data center and rack number. And but we don't have any data. The cluster.
So this management interface that you're showing there runs on Yugabyte on the individual nodes automatically and comes as part of it, basically. So
it's a standalone process. Like in YugabyteDB, when you start a YugabyteDB node comprises several standalone processes. You have Postgres backend. It's literally Postgres with modifications that runs and listens on a defined port number. That's your query layer. And then you have another process for the storage layer of YugabyteDB where we store your actual data and execute queries. And then you have the standalone process for the UI. So I can connect to this. That's the instance of the UI for the first node of the cluster. Okay.
But it's part of the open source YugabyteDB project to have all this nice UI and stuff.
Exactly. It's open.
Very cool.
And here, as you can see, the names, right? I decided not to be way too creative, and the names for these nodes is YugabyteDB _ node number 1, node number 2, node number 3. This is how the nodes can discover each other, and this is how the application and Trino will be able to discover the cluster within this Docker container environment. Okay. So let's switch Trino. So let's do this for now. I will exit from my Trino shell, and I will go to the, I have this Trino properties. Let's copy this Postgres properties to YugabyteDB file. Once we do this and once we update the configuration, we will have the YugabyteDB data source available for Trino. So here is, we don't want to touch this property because this is what Trino supports. We just need to tell Trino that, Trino, hey, you're going to work with Postgres, so please use your Postgres implementation for this data source. Use JDBC driver. Also, we are not going to change this beginning of this URL because JDBC Postgres, we are going to use the same JDBC driver. But here is we are going to be, this is what we are going to adjust. We know that we have YugabyteDB node. Let me close this one for now. YugabyteDB node number 2, right? And it listens on this port number. And also and this is actually already enough. You can just go this way. I'm going to connect to YugabyteDB database. The username is going to be Yugabyte. And guess what? The password is going to be also Yugabyte. It's impossible to forget. But the standard driver of Postgres allows you to define several connection endpoints. For what? For fault tolerance needs. For instance, if the driver loses connection to your primary endpoint that goes first, then the driver will automatically connect to the next endpoint that is listed in here. So we know that we have YugabyteDB node number 1, same port, and we also have YugabyteDB node number 3. That's for the cases if we get to the fault tolerance demo. I'm going to kill node number 2, but then I want Trino to continue its operations and use the remaining nodes. So these connection, the driver will be opening connection to these nodes only when the first one fails or becomes unavailable. But the Postgres driver has another interesting parameter that I want to show you folks. It's called, let me Google for it. It's called Postgres JDBC multiple endpoints. I'll find it. Initializing driver, connection failover. It's called load balance hosts. If you set this parameter to true,
then it'll round robin through all of them.
It will round robin and it doesn't need to wait for the failure. So basically, during the normal operations, the driver will be opening connection to several YugabyteDB nodes, which is better from the from the load balancing perspective. Trino will be sending multiple requests, and if Trino opens and maintains multiple connections to the YugabyteDB data source, that you will be round robin, you will be sending requests to different YugabyteDB nodes.
How
Okay.
sophisticated is that load balancing? Is it just kind of like 1/3, 1/3, 1/3 in hopes that the workload gets distributed evenly, or is it aware that one node is being heavily used and will use the other?
I don't know, my friend. Actually, what I learned from this documentation, and I didn't look in the source code, they just say that they open when you define this property, they will start opening these
Okay.
connections randomly. They will just use some random number and decide like which one node will be used for the next connection. That's all I know.
Well, that can be homework for our viewers then, as they can go look into
Yeah.
that and
Play
report
around with
back
it.
in the YouTube comments.
Exactly. All right, so we defined this YugabyteDB properties file under the Trino catalog directory. Okay, so now let me restart Trino so that it picks up. By the way, do I really need to restart? Because I was reading that you don't support dynamic catalog changes yet, or is it already supported?
It's implemented. It's not yet documented, but it does work to create and drop catalogs on the fly via SQL statements. Altering you doing it, changing it is not yet supported. But it's all in progress and coming.
Soon, eventually. Pick one of those two words, one of those two. It's sooner, eventually, it'll be there.
Yeah, it makes sense. It makes sense.
Creating and dropping already works.
Yeah, at least, yeah. This one, I know for sure it will work. Okay, so we restarted Trino, and now let's connect back to our container. Okay, fingers crossed, show schemas, not from Postgres, but from YugabyteDB. Okay, we've got schemas, and actually we've got the same schemas.
Oh, same.
Because let me show you this. We have this nice UI, and this new UI is a new addition to YugabyteDB. This is actually what we created for our managed service. And this is the UI of the managed service, but then we decided to open source it. And that's why it looks so nice. But our earlier UI is running on this port number. It's more detailed. It's not that fancy, but it can let us look into their more detailed stuff like tables. Here, as you can see, this PG underscore table spaces, type, attribute, pros. Those are the tables from the PostgreSQL catalog. And this is why, like, when you have some application tool or driver or framework created for Postgres, it's highly likely that it will work with YugabyteDB because we are effectively Postgres. We support Postgres catalog, error codes, everything, because we run Postgres internally. And if we repeat, as for the tables, really quick, show tables from YugabyteDB public. Nothing yet, right? We need to switch our application. So I stopped my application. Let me also, just in case, remove this application container. I will recreate it from scratch. And then this version of the container, we are not going to change anything on the application end, but this properties file. So this is the properties file that the application is going to use for the connectivity. So we can also use the same driver, the same PostgreSQL driver for YugabyteDB, not a problem. But I am using the smart driver of YugabyteDB. Why it's smart? It's a fork of Postgres driver. It's just the Postgres driver that comes with some YugabyteDB specific stuff. What's the difference? So here, as you can see, that by default, the driver will be also connecting to this YugabyteDB node, number 2. But once the driver connects to this node number 2, it will learn and load IP addresses of the other 2 nodes automatically. So it allows you to dynamically monitor the state of the cluster topology. You add new nodes, you drop some nodes, the driver keeps track of the current nodes that are alive, and it will be using those IP addresses dynamically whenever it's needed. This is what the standard driver of Postgres doesn't support, because Postgres doesn't have this capability. We have this additional endpoints parameter, but this one is used only during the connection time. When you start, let's say, your application, then the application needs to open the first connection, and it will try to open the first connection using this node. But if this node is not available for any reason, it will connect through any of these nodes that are listed here. Once connected, it will also load dynamically the other IP addresses of the other nodes. So that's what we have. Let's start this application.
I feel like that YugabyteDB Postgres kind of JDBC enhanced driver answers kind of Cole's questions from earlier. Like it does kind of that sort of like smarter balancing and stuff. It's really cool.
Exactly. So right now, we are creating the schema. It takes a little bit more time here because DDL is executed longer in our distributed database, considering Raft consensus protocol, but I don't want to go into the details. But eventually, we've got the same application running right now. So let's go back to Trino. Let's execute the same request. Do I have my tables? Yeah, I have my tables, the same tables. And now let's run this simple experiment. For instance, I want to query the most popular stocks. But right now, I'm querying this from the YugabyteDB trade table, okay, not from Postgres. If you run this query, it will be executed across all of the nodes, and then Trino will get your final result. And here is what you can see. That's what it was returned from Yugabyte. If you keep executing what I have, this is, for instance, the most active traders. Also, we are querying this data from YugabyteDB. I noticed that it takes more time to execute this over YugabyteDB than on Postgres on my machine, but that's the problem with my YugabyteDB image. It's not
you're running a
optimized
lot of stuff now. It's just a laptop, right?
And it's also it's not optimized for this AMD 64 configuration for Apple M1 CPU, while Postgres is optimized. That's my problem. But generally, the latency, the performance is comparable. So this is what you need to have between Postgres and YugabyteDB. Even when you scale to distributed database, you introduce the network latency. But at least if you maintain the same latency and performance, when you compare to standalone Postgres server, it's already a good big win.
Yeah, and I think the advantage is worth highlighting is that latencies should be about the same, but bandwidth is where YugabyteDB is going to begin to take off at large scales where Postgres can't handle it. YugabyteDB will, right?
Exactly. Yeah, that's the right point. So what else, right? We know that Trino supports federated queries, and we still have our Postgres database running, and Trino is still aware of the PostgreSQL existence, even though the application no longer writes any data into the Postgres instance. But why don't we run, say, this federated query? What this query does, it returns the most popular stocks from the historical data, and this historical data is in our Postgres database. Like, imagine that we just still have this database and all the history is there, and we are joining this data with the latest information that is in the YugabyteDB. So we just select from YugabyteDB, we join it with the data in Postgres, and then we join on the same symbol number. Like, let's say we have information for the stocks for the Google in Postgres in YugabyteDB, and I want to get this final total, let's say, like what was the most popular stock across all of those two databases. Let's run this federated query. And here is what we've got. So here, as you can see, that's the actual information that is stored in our YugabyteDB. And this is the total for Google. And it definitely took something from Postgres. If we take a look at Postgres, for Postgres, it's in here. Yeah, we still have this request for Postgres. No, not this one. This one. This one is for Postgres. We also have more than $50,000 spent on Google. And this is your federated query. In general, you're going to have more than 100,000. Yep.
That's very cool. And that kind of federated query obviously could also be where the old data is not in Postgres, but in some data lake or whatever, right? So that's really
exactly. It's like this is the job of Trino, right?
Yeah,
you can do like whatever you want. We basically just showing that. Yeah, we had that probably. Let's say usually when you migrate from one database to another, you also migrate data. But let's say that we decided no, we don't want to migrate any data from Postgres. Let it remain in Postgres, but we still need the data for reports, and we can run those federated queries across multiple databases. Okay, final one. Let's disrupt this workload a little bit. We know that our Trino connector and the application are connected to the YugabyteDB node number 2 by default. So that's the primary connection endpoint. And then there will be other connections that are open to the other nodes. And right now, let's say that something bad happened in the data center when that node was running and the node went down, it became unavailable. So for that, to simulate that outage, we are going to use just this docker stop command. I will stop this node number 2.
You're pulling the power cable out of that server rack.
Exactly. So now also let me run this query from Trino. So generally within several seconds, what happens right now? Usually within 3 seconds, YugabyteDB internally detects the outage. It's like, and then the nodes will detect that, all right, node number 2 is no longer available. Then they will start the Raft consensus protocol real action, because they need to decide who is the owner for this data that previously belonged to node number 2, etc. And then this issue will be propagated to the upper level, to the driver, to Trino, to the application, and the application and the driver need to refresh the connections. So based on our calculations, if to consider, like for YugabyteDB usually detects and does the real action within the 3 seconds window, but considering all the network-related timeouts, default timeouts, it can take up to 30 seconds. You will see this pause in your workload. You can see some, exceptions if some of the connections will be broken right on the application end, but the application will open connections with the other nodes that are alive. The point is that you're not losing any data. That's a transactional database. That's the point. We cannot afford losing any data.
Yeah, it's also like cool to observe, right? Like on the right-hand side there, it just keeps writing, like didn't care at all. Like the application just keeps running, pumping data in. The database server wanted and disappeared, but it's completely unfazed by that.
And also remember the cool thing that is related to Trino. We stopped YugabyteDB node number 2. And let's remind ourselves what was their this node number 2 was the first, which means the default connection endpoint for our Trino connector, which means that Trino also did not experience any outage. It had some delay while the cluster was, figure out everything. But right now, you don't need to restart Trino. You don't need to change anything. Like the driver is connected to the other nodes, and Trino keeps running without any issues.
And now the queries are quick again. Once it figures it out that one time, it's back to basically being full speed, yeah?
Yep. So let me, this new interface. So on this new interface, you can see that, this node is down. It's no longer available. But these remaining 2 nodes keep handling read and write workload. You can see this non-zero number under the reads and writes for both nodes. If you, answering your question, Cole, let's assume that data center availability zone is restored, and now we can bring the YugabyteDB node back to the cluster. We do this by starting this container. And generally, it's better to observe here. You'll see that soon this node will join the cluster.
It just boots up and then broadcasts some sort of a live symbol.
And there it is.
It's already here. What I'm waiting right now, you see this leader and peer. Leader is like how many charts, tablets this node is primary for. So this information, you see, it's being updated because right now you've got another database server, and we want to distribute data evenly, which means that the cluster internally, does this resharding, data rebalancing. And as long as this has happened, right now you can see that all of the 3 nodes are handling your read and write workloads. And just in case to confirm that Trino keeps working, executing the same request against YugabyteDB. Yeah, it works.
Awesome, cool. So question about that. So how many servers do people typically have in a cluster, or what's the kind of range? And are these do people typically have sort of average or medium or really large servers and fewer of them? And then also, where is the storage for that stuff?
Yeah, so the minimum number of servers is 3. And why? Because we use Raft consensus protocol for your data synchronization. When, let's say, you have this YugabyteDB node number 2, and that node is responsible for my customer data. You update my customer record. So this node receives this update, and then it uses the Raft consensus protocol to synchronize this change to the other 2 nodes. And according to the Raft consensus protocol, if you have the replication factor of 3, you need to have the consensus of 2 nodes to allow a change to happen. Which means that when you have the 3-node cluster, you can lose one of the nodes, and your cluster will continue operations with 2 nodes. But if you lose more than 1, 2, then the cluster, you will have 1 node. That node will keep all the data, but it will not process your request because it cannot reach the consensus. For the consensus, you need to have at least, let's say, 2 nodes. So 3 nodes is a minimal. When it comes to the maximum, it depends, because YugabyteDB can scale vertically and horizontally. I mean, like some companies and users run it on upscale machines, some run it on commodity hardware. It's okay to see, let's say, dozens of nodes cluster, like 9 nodes cluster, or hundreds of node cluster. It all depends on your use case. And also you depend like on how you want to deploy it. You can deploy YugabyteDB within one single region across multiple availability zones, or across several regions in the cloud. And there are various database configurations for different, let's say, for different needs. That's what I would say.
So if you're running across multiple clouds, then there's somehow like not to go transfer data too crazy back and forth because that gets expensive, or how does that work?
So you can do, in YugabyteDB, we have so-called, you can deploy standalone YugabyteDB clusters in every cloud environment, and you would have asynchronous replication between them, asynchronous. So this is what every database supports, But you can also deploy so-called geo-partition cluster. For instance, let's say that it's a single cluster, and you can say that, okay, I have customers in the United States, Europe, and Australia, and I want their data to be located in the place where they live. For instance, if I have some users from European Union, all their data will be automatically placed to the European data centers. Or if you have users from Australia, it will be stored in Australia. It's possible to run, let's say, cross-region requests, like, let's say, pulling and updating data, let's say, from Australia. You can read data. If you're in Australia, you can read data from the United States or Europe, but at a higher latency. But whenever you, let's say, you update any records and you are in Europe and all those records belong to Europe, the latency will be very low. So we call this geo-partition cluster. You just need to define a special column in your table, and based on the value of that column, the database will automatically place or read the record from a specific region. And you can take this geo-partitioned use case and deploy a cluster across several clouds if needed, right? So people do this sometimes, or they just deploy standalone YugabyteDB clusters and set up asynchronous replication. But with asynchronous replication, your recovery point objective, meaning like how much data you're going to lose, right, if there is an outage, is not 0. Like with synchronous replication within a single cluster, it's always 0, meaning that you're not losing any data regardless of the outage. With the synchronous replication, no, it's possible that some of the data will not be transferred and something breaks in the middle, if something breaks in the middle. All right.
And then from Trino, you could query the separate ones or whatever if you wanted to, right?
Exactly. And with Trino, I mean, Trino, so what we did here, I'm just, specified these multiple nodes in here for their fault tolerance and load balancing needs. But let's say you have other YugabyteDB clusters or other YugabyteDB nodes, you can just create another properties, right, under the catalog, under the different names, and you can connect to them directly.
And then run federated queries even there potentially if you wanted to.
Exactly.
Very cool combination. The possibilities are endless.
Yeah. Thank you very, very much for the demo, Denis. I think you've done a good job of highlighting how to get started, how it works, what the upsides are. It's a fascinating piece of technology, and I think YugabyteDB and Trino make sense together in the sense of scale and reliability is all you really want with these two things, and it delivers that in spades. So
Exactly. What resonated with me when I was reading about Trino for the first time, you say that like Trino is a distributed SQL engine for analytical processing. And when I read distributed SQL, we also categorize YugabyteDB as a distributed SQL database, but for transactional workloads, when consistency matters, low latency matters, etc. So that's why both belong to the distributed SQL landscape, but one is for OLAP, another one is for OLTP.
Exactly.
Yeah.
Well, it was a pleasure having you, and we have a couple more bits of housekeeping to wrap up the episode with. But if viewers want to learn more, you can check out the YugabyteDB website, the Yugabyte website. Dennis, anything else you want to plug or mention if people want to read or learn more?
Oh, just you can find me on Twitter, Fox on LinkedIn, etc., and just have fun building scalable applications with Trino and YugabyteDB.
Well,
and
thank
our
you.
show notes obviously will include a link to a very cool blog post that details all this demo that Dennis has done, as well as links to the other YugabyteDB resources and Dennis's details as well. So thank you again. That was really cool.
All right.
Thanks a lot. Thanks for inviting
And
me.
Manfred, we have fun, exciting things coming down the pipeline on Trino to talk about. So I'm gonna play the I cut you off there with the button, but
yeah, no, it's there's a lot going on. We just had the SQL training last week. It feels like long ago already, but it was only last week. And I'm preparing material for next week with Martin, which is going to be super interesting to learn more about all the power of SQL in Trino, where we aspire to be as good as PostgreSQL, which is arguably the best implementation of SQL standards. We're very close, and we got some really cool new features coming up as well. But in that training series, we'll dive into all the details. But lots more is going on in the Trino community as well, beyond the training series. What's coming up in December, Cole?
Yeah, so the Trino Summit, we mentioned it in last episode, but it bears repeating. It's coming up on the 13th and 14th of December. It's fully virtual, so you can sit at home in your pajamas with some hot cocoa and enjoy listening to the lineup of talks. We've got some speakers getting finalized now, but we're still open to more. So whether you want to listen or whether you want to talk, consider taking a look at those links to submit a talk or register to attend, and we'd be happy to have you. And of course, as with all Trino events, all talks will also be video on demand available after the fact, if you're just not available for some amount of time.
Yeah, if you have a cool demo like what Dennis just done or anything else on an application, some of the other things we showed in the Trino community broadcast in the past, or also you're using Trino at your company with some custom implementation or just experiences with Trino or Trino related products, we would love to hear from you all. And I'm sure the community will be patient with you. And if you don't feel too comfortable about presenting, we can help you along. It's pretty easy in the end, right?
Yeah. Also coming up is a talk with Slalom and Starburst in the Bay Area. That's going to be in Redwood City. You can click on the link there if you want to find more details. I'm currently slated to be speaking at that. So if you want to visit me in person and you're in the Trino community in the Bay Area, Silicon Valley, consider signing up and checking that out.
What are you going to talk about, Cole?
It's going to be about data lakes. Though here's the thing, as I was going to spoil it a little bit, is we might be upgrading me to Martin. So
ooh,
you could get an even better speaker. I'm not going to claim to be as fascinating as Martin is when he's been working on Trino for as long as he has. But I'll click on the event.
I mean, Martin worked on Trino over a decade, but you've been on Trino quite a long time too, Cole. So don't be too modest. You'd be a great speaker too.
But so we'll be talking about Iceberg and data mesh. And it'll be about an hour of talking, and the event is 2 hours, so shouldn't be that big of a slog. And whenever I'm full screen, I'm unable to click the back button, so I have to unfull screen and click the back button, and then go back to full screen.
It is confusing. So people are gonna have a chance to go and meet you in person there, or Martin, or both, and maybe even go away with a Trino t-shirt or something like that. You think?
Yeah, there may be swag, but you'll have to show up to find out.
Well, that's cool.
In any case, Manfred, there was one other thing. Do we want to save that for a future Trino community broadcast episode, perhaps? It seems like we're running low on time.
I want to just mention it because it's super exciting, and we've been working on it so hard. So Dane, David, Martin, and myself been working crazy hard. I'm just doing the documentation, so that's the easier part of it all. But we implemented a new feature in Trino that's a long looked for feature. In the past, if you wanted to write a custom sort of function, you needed to write it in Java, create a plugin with the right version of Trino and deploy that and so on. Now you can write it in SQL. So you can go create function, begin, declare variables, if then else, case, blah, blah, all that kind of stuff right there in your SQL console in your CLI, and it can get stored and everything. So super exciting and powerful feature. And we merged everything yesterday and been crazy going at it. And we just have a little release blocker, but it's going to come out in a day or two, maybe even today. I'm so excited. It's going to be awesome.
We'll see. And you'll probably hear more from us about this because this is a big deal. So this is not the last you hear of it. Stay tuned to the Trino channels for more information. Manfred
me and Dane will demo it in the SQL training episode as well. So, and we'll have some cool stuff happening there. So
sign up for the SQL training series.
And Trino Summit.
Yeah, and if you're in the Bay Area for the Starburst and Slalom Talk, pick your favorite or all three. Do all of them. In any case, thank you all for tuning in. Thanks once again to Denis for being here to speak and give us such a great overview of YugabyteDB. And that's going to be us signing off. Thank you to everyone for watching, and we'll see you next time.
That's right.
Music for the show is from the Mega Man 6 gameplay album by Krzysztof Sławikowski. Don't forget to give us a star on the Trino repository at github.com/TrinoDB/Trino. And for more information on future shows and to find show notes, check out trino.io/broadcast.